On this 2019 to 2024 Ram 1500 Classic with the 3.6 Pentastar P0010 is for the Bank 1 camshaft position actuator control circuit, specifically the VVT intake solenoid 1/1 control side. In plain language, the PCM is seeing a possible electrical problem in the intake cam VVT solenoid circuit. The vehicle may turn the MIL on, and if it is stop/start, that system can be disabled while the code is active. The fault area is often wiring, connector condition, the solenoid control or ground side, the solenoid itself, or in the last part of the path, the PCM. Treat this like an electrical circuit diagnosis, not a mechanical timing diagnosis. Start with the basic system checks. The monitor runs with the engine running and battery voltage greater than 10.4 volts. Before chasing the circuit, scan all modules, record the codes and captured operating data, save the vehicle scan information, then clear the codes. Turn the ignition off for a minimum of 10.0 seconds, turn it back on and reproduce the operating conditions that set the fault. Read the codes again. If P0010 does not return, handle it as an intermittent condition. If it does return, continue into the circuit checks. With the ignition off, go right to the VVT intake solenoid 1/1 connector. Before unplugging it, make sure it was fully seated and locked. Then disconnect it and inspect for pushed out, damaged, or spread terminals. If you find a connector or terminal problem, repair the terminal issue or seat and lock the connector correctly. Then verify the repair and confirm the code stays gone. If the connector and terminals look good, move on. Next, check the VVT intake solenoid 1/1 K76 control circuit for a short to voltage. Turn the ignition on and measure voltage on that control circuit at the solenoid harness connector. There should be no voltage present, except for a brief moment right after the ignition is turned on. If voltage is present beyond that brief normal pulse, repair the K76 control circuit for a short to voltage, then verify the repair. If there is no voltage, keep going. Now check the same K76 control circuit for a short to ground. Turn the ignition off, disconnect the PCM-C2 connector, and check continuity between ground and the K76 control circuit at the VVT intake solenoid 1/1 harness connector. If there is continuity to ground, repair the control circuit for a short to ground and verify the repair. If there is no continuity, continue with load testing. Isolate and load test the K76 control circuit for an open or high resistance. Do not load test any circuit while components are still connected to that circuit. With the circuit isolated, the load test bulb should be illuminated and bright, and its brightness should compare to a direct connection to battery. If the bulb is not illuminated and bright, repair the K76 control circuit for an open or high resistance, then verify the repair. If it passes, go to the ground side. Load test the VVT intake solenoid 1/1 Z908 ground circuit at the solenoid harness connector. Again, do not load test the circuit with components still connected. The bulb should be illuminated and bright, and you compare that brightness against a direct connection to battery. If the bulb is not illuminated and bright, repair the Z908 ground circuit for an open or high resistance and verify the repair. If the ground circuit passes, move to the PCM driver operation check. Reconnect the PCM-C2 connector and turn the ignition on. Use a 12-volt test light connected to ground and probe the K76 control circuit at the VVT intake solenoid 1/1 harness connector. The PCM may command the solenoid on briefly right after key on. That brief flash is normal, and the light should then turn off and stay off if there is no short to voltage. Then use the scan tool to actuate the VVT intake solenoid 1/1 control to the highest duty cycle, 80%. The test light should be illuminated and bright, compared to a direct connection to battery. If the light is illuminated and bright during the commanded actuation, replace the VVT intake solenoid 1/1, then verify the repair. If the light is not illuminated and bright, continue to the connection checks, before condemning the PCM. At this point, handle any applicable bulletins, then inspect the PCM connectors, related inline connectors if equipped, and related component connectors. Look for poor seating, damaged locks, corrosion, water intrusion, whether seal damage, bent terminals, overheated or discolored terminals, push-back terminals, spread terminals, and poor terminal tension. Repair any condition you find. Reconnect everything fully, make sure the locks are engaged, clear the codes, and operate the vehicle under the monitor conditions again. If P0010 does not return, the wiring or poor connection problem has been repaired. If it does return after these checks, the diagnostic path supports replacing and programming the PCM, followed by repair verification. The clean path for P0010 is to prove the code returns. Inspect the solenoid connector first, then test the control circuit for short to voltage, short to ground, open or high resistance, and load test the ground side. Only after the wiring and connector path passes do you use the driver command test to separate the solenoid from the PCM side. Verify the repair and confirm the code stays gone. For more diagnostic training, visit stepdiagnostics.com.